So good morning, everyone. Welcome. Very glad to have you here in the continuation of our webinar series. I'm Anna Stiefken with the Scott Institute for Energy Innovation at Carnegie Mellon University in Pittsburgh, Pennsylvania. And we are extremely excited to have this group of experts with us today to talk about energy and batteries and storage. So quick update, I wanted to give people my contact information because this is a great way. Many of the topics have been posed by others. So if you have a great topic that you'd like to discuss, you can certainly get in touch with us. We actually also have ways that you can submit things and follow us online. So I always want to make sure that I include our social media information at the very beginning. So who is the Scott Institute? We are the research hub for energy and technologies at Carnegie Mellon. And we focus on strategic partnerships, on educational opportunities for our students, on entrepreneurship, and obviously on the research of our faculty. So this webinar is really on COVID, but we're really sort of pivoting into what we need to be thinking about for the future. So we bring together folks with operations and policy strategy backgrounds to talk about important topics. So today's topic, as I mentioned, is batteries and the future of energy storage. Very excited for our guests here today. A special thank you to the National Energy Technology Laboratory, the Pennsylvania Department of Environmental Protection, and Sonova for letting us borrow their extraordinary experts this morning. I want to do a couple of quick introductions. I'm going to start first with David Altoff. So David has worked at the Pennsylvania Department of Environmental Protection for over 28 years. 22 of those years have been serving in key roles within the state energy office. Next, we have Briggs White, who serves where he manages 3 research and development programs on behalf of the Department of Energy's Office of Fossil Energy and Carbon Management. And those 3 areas include high performance materials, water management, and energy storage. Anouk Shamshwar is part of the industrial biotechnology investment team of Sofinova Partners, but she co-founded XL Batteries, which is a New York startup developing organic redox flow batteries for grid scale energy storage. And then finally, we have Jay Whitacre, who is the CMU Trustee Professor in Energy. He's the director of the Wilton E. Scott Institute for Energy Innovation, and he's also a professor in materials science and engineering and public policy. And he works specifically on synergistic fields of energy storage and energy systems. So the perfect complement and moderator for our day today. And with that, I'm going to pass it over to Jay Whitacre.
Okay. Thanks very much. And I'm going to sort of take over and drive this bus. The first thing before we get into the real questions, though, is I want to familiarize the audience a little bit more with who these folks are. We just had this fantastic brief introductions that Anna gave, but I'm going to ask everybody to give like 2 sentences elevator pitch. What do you do every day and how does it relate to storage? I'll start as moderator. As a researcher, I've done a lot of work in energy storage. I investigate new materials, understand how those materials integrate into battery cells and packs and systems, and then I talk about it and research the economics of those as well. And I also founded a company called Aquaon Energy that scaled and produced tens of megawatt hours of batteries and shipped them worldwide. And then got acquired at a huge loss in 2017. So I have actually seen the commercial industrial part of this as well and have some interesting perspectives around all that. So I'm really eager to hear what these other folks have to say. Briggs, let's go to you.
Thanks, Jay. As a technology manager at NETL, I work hand in hand with my headquarter counterparts in DOE's Office of Fossil Energy, where we have a real big focus on decarbonization. And internally to NETL, I work with a team of experts, folks that do systems analysis, markets analysis, as well as actual experimental R&D at the bench. And of course, with numerous external partners at universities, national labs, and private sector industry companies to advance technology and create knowledge.
Great. Let's go to Anouk next, please.
Hi, everyone. It's great to be here. So currently I work with an investment team at Sofinova Partners looking at early stage industrial biotechnology startups across chemistry, materials, food, and agriculture. So no energy storage actually, but companies using sustainable biotechnologies. And prior to that, I co-founded a energy storage company and have a background in chemistry.
Great, thanks. Dave, how about you?
Thanks. Good morning, everyone. And so I'm Dave Altoff. I'm the director of the Energy Programs Office, which is the Pennsylvania State Energy Office. And we are uniquely situated within the Department of Environmental Protection. So our Energy Programs Office, as the State Energy Office, really helps, carry out DEP's mission of how do we reduce environmental impacts. Interestingly, the State Energy Office also includes working together with PEMA on energy assurance, provision of energy in Pennsylvania. So therefore we can go about our daily lives and do the things that we need to do. But also we are also in charge of the climate program. And so with this sort of unique set of responsibilities, clean energy technologies becomes a very, very important role in how we sort of fulfill all of our missions with the State Energy Office within the Department of Environmental Protection. Certainly batteries and energy storage are part of that clean energy technology and clean energy economy that gets discussed a lot. So that's my role here today, is to sort of thread that needle between all of those things.
Perfect. Thanks so much, guys. I really appreciate it. I'm hoping that this gives the audience a bit more flavor, so when you answer, they get a bit more from where you're coming from. I'm going to now go through and ask each person one or two questions in sort of a round robin fashion. And I encourage everyone to also comment and chime in. Everyone, either if you're in the audience, you hear something that you want to hear more about, please send a chat question. Or anyone else on the panel, please also chime in if you have anything to say during this process of these round robin questions. And at the end, then we're going to have some open-ended questions that we can all sort of talk through. My guess is one or more of us will have an idea that we can all build on. I'm going to start with Briggs. First one, I'm going to sort of go at, given your position in sort of the momentum that we see now in the national labs in general around energy storage. I'd like you to talk a little about how NETL is getting sort of integrated. And those of you in the audience who don't know, NETL is the Pittsburgh-based energy lab, that DOE energy lab, National Energy Technology Lab, that is historically focused on fossil fuel technology and integration, but they're delving into storage now, which I think is exciting and appropriate. And I'm really curious to see sort of what their perspective is, and specifically how it ties to fossil energy sources, power sources, and what the future looks like, and why is NETL getting involved with this? And I guess as a follow-on, how are you integrating with other national lab efforts? This is going to be sort of a big cross-cutting effort going forward, I think, in DOE, and I'm curious to see how NETL looks to fit in.
So thanks for the question, Jay. And you're right. 2 years ago, Congress appropriated money for the first time to DOE's Office of Fossil Energy to stand up an energy storage program, actually as part of a DOE cross-cutting initiative that brought together all of the offices, so nuclear, fossil, of course, energy efficiency and renewable energy, which has the vehicles program, importantly for electric vehicles, where a lot of battery work goes on, as well as, of course, the Office of Electricity, which does the grid scale electricity work. And how we fit in is we found a unique niche that I think really is different than what those other programs are working on, in the sense that they're going to work on, making batteries and the supply chains for them better for electric vehicles. Other programs are going to work on grid scale storage. What we're going to be focused on is the connection between energy storage and fossil power generation or other fossil fueled assets, really because it helps with taking us to the vision of the future where, yes, we're going to have lots of variable renewable electricity on the grid. I think everybody accepts that's a future that's going to happen. But as we get up into that 50, 60, 70% VRE, if that occurs, we're going to need low carbon dispatchable energy. And that energy is going to have to be really flexible. So energy storage provides an opportunity there where, yes, we can operate, say, a natural gas combined cycle or a coal plant with CCS, which mitigates the carbon. But CCS units typically want to be operated flat out under sort of base load conditions. And energy storage provides a really nice opportunity to increase the flexibility of that dispatchable power while creating low carbon energy. So a hybrid kind of application like that is not something that the audience might be super familiar with. You're thinking of batteries for EVs. Here we're talking about connecting energy storage, and typically it's not batteries, it's say thermal energy storage, chemical energy storage, or some other medium to long duration energy storage technology that can be connected with a fossil power generator in sort of a low carbon setting.
Great. Yeah, I actually have just been starting to think about things like you just mentioned. The idea of optimizing the efficiency and performance of a CCS plant by buffering it with storage is really intriguing. It allows you to sort of run it at exactly where it wants to be without having to match load at all, and may allow for a lot more proliferation. So great. Thank you very much. I'm going to pivot to David now. David, as a director of the program that you have, what kind of advantages do you view storage bringing, and how, and given the various programs that you're sort of overseeing or part of, the kinds of things that Briggs is talking about and the kinds of things that exist elsewhere, what are the advantages and why would you do it? And the follow on really, in my mind, is do the economics support it right now and what might be needed?
Yeah, that's a great question. Thanks, Jay. And yeah, I'm going to also sort of tag on to what Briggs was talking about. I mean, for us, energy storage just checks a lot of the boxes relative to the goals and mission of our office, which I described earlier. We want to be able, excuse me, to enable energy resources to be there sort of in the critical moments from a resiliency standpoint. Resilience is a big part of the conversation these days relative to climate, relative to our energy resources. You point towards Texas and other things that happened recently. And so, how do you have a resource that's there for the critical moments? And what does a critical moment mean? We also need to create confidence in sort of clean and renewable energy technologies and sort of this intermittency discussion. Batteries help sort of help bring that discussion to the front and say, well, what can we do to sort of mitigate that? And I think that batteries are for us in the unique position of being something that is sort of technologically next step, but it's also something that people do understand. It's not as if folks do not use batteries in their normal everyday life. It's not as if it's a brand new technology nobody's ever heard of before. Everybody's using a battery today in their daily life for sure. So what are we going to do with battery technology? And as Briggs says, in reality, we're really talking about thermal technologies here from the standpoint of the grid, from these critical moments to creating confidence in these intermittent technologies, not simply like the battery that's in your flashlight or in your phone. But that being said, it's all within that same framework. Recently, in our office, we put together a PA energy storage assessment, a sort of a status, barriers, and opportunities report, and it's up on our website. And we really did that to just sort of bring out for policymakers, for folks who want to know what's going on in Pennsylvania with regards to energy storage, who's working in this area, what are some things that we should be doing going forward for planning. We want to put together an energy issues storage forum or an energy storage issues forum, because we think we need to talk about these things because there's opportunities in Pennsylvania for us to lead on this. And to get towards the second part of your question from the standpoint of, economics around this, I think that folks will pay for things that have a lot of value to them. And we need to discuss what the values of energy storage are, how to specifically identify and then create a value chain such that it makes sense and this is worthwhile, and that energy storage can be valued in our grid, in our distribution grids, such that it removes other costs, whether that be infrastructure costs, whether that be deployment of additional energy generation, the need not to do that. So I think that all of what comes with energy storage needs to be discussed, fully discussed and understood. And it's an opportunity for us to build, manufacture, and deploy this technology in Pennsylvania. This is something we can easily be a leader on, and it should be part of our economic development around clean energy in PA.
Great, thank you so much, David. I also just took the liberty of posting the PA media presser on this report, Pennsylvania Energy Storage Assessment Status, Barriers, and Opportunities, that I posted to both the attendees and the panelists. So if they want to peruse it, and it might fuel some deeper investigation, and maybe even in real time if people want to look at it and ask some questions. Thanks. Anu, so you come at this from a different perspective as well. You've been on sort of the front lines developing new technology, trying to understand where it fits in. And that's the sort of the first chunk. And the other chunk is you now exist in the VC community that, maybe not directly you, but I'm positive colleagues and friends of yours make decisions daily about whether or not to fund different storage technologies and what the future might be in terms of venture development. What's your perspective on the future of energy storage, either technically or just as a developing sort of concept that has a role in the energy marketplace?
Yeah, that's a great question. So I can answer this more from a tech development perspective from the early stage, especially the flow battery space.
Sure.
So what really interested me and surprised me when I started learning about this field is how little storage capacity we currently have today. So I was in chemistry and materials, but didn't necessarily know much about storage. And I was also surprised to learn that most of the grid storage capacity in the US is from pumped hydro, which is geographically limited. So this kind of plays on to what David was just talking about, just speaking more of this and becoming more educated about like what are our actual options today. I think going forward, what we need is more and cheaper storage. So I also think we need to be looking at technologies that work with abundant materials. Flow batteries are particularly interesting because they allow for flexible duration because the designs decouple energy and power. But a big challenge for these technologies is cost and scale, or cost and scalability of the chemistry and of the materials. So yeah, I think a critical requirement of any kind of long duration storage is low cost per kilowatt hour. And as I said, yeah, technologies based on cheap and abundant materials. Yeah.
Got it. And just a quick follow on the audience. We just got a quote, as a question to the panelists from one of the attendees. Could you briefly describe a flow battery and differentiate it from other battery technologies? I think it's an important.
Yes.
But the audience is a bit more general, perhaps, than
Yeah,
a
sure.
deeply technical audience.
Sure. So I think most of the batteries that we're used to everywhere around us are really designed for portability, and they're designed to be light. So they're batteries that are in our electronics or in our cars and electric vehicles, like the one Jay is holding right now. And so these are based on lithium ion technology, which has been designed to be light and portable. And the kinds of batteries or flow batteries are different in that what you really have is two big tanks separated by a membrane of sorts. So I'm kind of explaining it crudely, but what that allows for, like I said, is to decouple energy and power. And what that means is you can really tune the size of the tanks and the size of the separatory membrane. And that allows for a lot more flexibility depending on duration and need, as opposed to lithium ion have the limitation that they're manufactured at a given size. So for example, like a Tesla battery is made up of like 8,000 individual little batteries wired together. And so as you scale, it becomes really about wiring more of these batteries together to get the big batteries. So it becomes kind of limited at these really large grid scale that we're aiming for long-term and grid scale duration or storage.
Perfect. Yeah, thanks. I mean, I think that question actually even opens up a larger can of worms for this panel, which is energy storage is not storing just electricity. It's thermal storage, it's chemical storage. Like, let's say you make hydrogen that you then can use for something else down the road. Some people even lump using renewables to produce other chemicals that are used for other things as a type of energy storage. You're offsetting electrical energy needs to use renewables to produce something, or use excess energy to produce something that offsets the need of electricity there or later. That's a form of storage too. So there's actually a really broad place, and it depends, a broad set of categories that often are lumped into what is energy storage. And I think, I encourage the audience, when you hear about energy storage, to not just limit your thoughts to, the battery that's in a Tesla, or something that you might put next to a house. That's the thing that we're most familiar with and we're most comfortable with thinking about. But instead, maybe think of a giant underground, gravel pit that gets extremely hot, and then that heat is then harvested at a later time. Things like that are also very valid and may even be cheaper and more integrated into some applications than electrochemical batteries. So that's an important message I think we want to get to the audience today, is that energy storage is a very broad category and there's many different ways to apply it. On the other hand, that makes developing it and harnessing it from a policy perspective very complicated, because all these technologies have different economic, location, technical drivers that change depending on where and how they want to be implemented. And so there's always a challenge in picking which ones to help encourage and develop and move forward with. So there's a bunch of questions coming in. Thank you. We'll get to those in a minute. I want to go through one more circle with these folks, and then we'll jump to these fantastic questions. So Briggs, there's a renewed interest now in quote unquote long duration energy storage. So this is for grids and application. And I'm curious what you think about when you hear long duration. What does it mean from your perspective? How does it fit into the paradigm of fossil integration and or renewable integration? And why is NETL interested in it in particular?
Sure. So we're interested in both medium term and long term. And I would argue that really anything beyond 4 hours, which is typical cost-effective lithium ion today, is probably getting into what, let's say, medium term, and probably 8+ 24-hour plus is getting into long term. But there's a lot of discussion. Yesterday, I was in a Power Magazine webinar focused on hydrogen, which was really focused on how do you deal with curtailed renewable energy, particularly in places like California, where you have all of this energy, you hate to lose it. And so can you do something with it, particularly in a seasonal kinds of context? And hydrogen is an example there. Of course, that's going to suffer from challenges related to round trip efficiency. You've got a lot of infrastructure to build out there, and there's going to be some cost challenges. And so there's interest in, well, what's the sweet spot? Do we really need, full-blown hydrogen energy storage, which is probably one of the only technologies you can use for long duration? Or can you get away with something else that's maybe a little more cost effective? And there's opportunities, for example, in thermal energy storage, where perhaps with low-cost materials like pebbles and sand and rocks, you have a material that has a really low cost entitlement. You can use a ton of that stuff and store energy in it for long periods of time. That may be a sweet spot at the end of the day. To Anouk's comment about low CapEx. I mean, low cost is really going to be the driver, along with efficiency. It's going to depend on the use case, as you said, Jay. But I mean, I think that there are some really interesting technologies out there, and it really just depends on the use case. Yes, cost is going to be important. Yes, efficiency is going to be important. But we also need to look at all those other things, including, as both of the other panelists said, what's the supply chain there, right? Can we make it here in the United States? Is it a secure supply chain that goes along with it? And perhaps that's an opportunity, particularly when we look at technologies that are not off the shelf lithium ion, where perhaps we can innovate it here in the United States and be sort of the, have a hand in our destiny, so to speak. So maybe I'll just stop there.
Perfect, thanks. I had a technical issue. I popped off and right back on, so I'm glad to be here. I was concerned for a second. That's perfect. A follow-on question about that. Well, actually, I'm going to move on. Actually, I want to say one thing first of all. I'm going to double down on how important economics are. Cost is, at the end of the day, most users, when they're consuming energy, they don't think about the technology behind it. They're thinking, am I getting energy or not? And am I paying a huge amount for it or not? Right. And so whatever we choose to integrate into our system to make it less and less carbon intensive and more efficient, and eventually, implementing more and more storage towards that mission, it has to be done so that there's not a massive increase one way or another. And the target keeps on moving for what is cheap too, I'll say. In 2008, 2009, when I first started thinking about this and working on my company concept, we believe that if we could get under $300 an hour per kilowatt, $300 per kilowatt hour installed as a technology, that it would be deeply competitive and would change the world, right? We actually got to that point where we were essentially able to manufacture at that price point. And by then, lithium ion, a couple of the technologies had passed us up and they were cheaper and it was still too expensive. So I think as the marketplace evolved to understand the costs and the needs and the CapEx limitations, the target became really difficult for a lot of companies. And there was this whole batch of energy storage concepts that initially looked really good that look less and less good based on a lot of these economic things. And so those of you out there who are interested in developing energy storage, any sort of technology, take the current cost targets and see if you can beat them significantly. If you can't, if you're going to come in high on them, it's probably something that you should consider trying to make it more economically beneficial and before you actually can hit on it. And so I'm going to turn to Dave now and ask sort of a corollary question, which is, it's getting less expensive, but it's still too much, right? If it was already economically competitive, we'd see more of it, I think, in general. There's a lot of interesting demos. Certainly some major energy storage suppliers are selling demos at maybe lead loss prices. It's unclear. No one really knows exactly what the economics are behind any given project, but that's one possible reality. Like, how do we get, we need to get to a next level though. And I'm wondering, Dave, do you think that the infrastructure bill that's coming up is going to be helpful? Do you think that there's other subsidies or lack of subsidies and other incentives that are going to help, like from a state administrative perspective? And states, remember, are the kinds of organizations that implement things like portfolio standards or other kinds of benefits that might help encourage storage. What do you think is going to matter in terms of cost, subsidy, and enablement?
So I think it's a great question. And I guess I'll start with, part of what we do in our office is to, like I said, educate folks. What is the current lay of the land and make some recommendations. Policy statements or things that come out from our office, from the governor's office, do send policy signals. And sometimes those policy signals also become market signals. I mean, I think we've seen this with our alternative energy portfolio standard or other states' renewable portfolio standards, whereby they say, hey, look, we would like to see some of this in the marketplace. We would like this to be mandated as a portion of the electricity mix or the energy mix. And it's both from a diversification standpoint, but also from an economic development standpoint. And, back when Pennsylvania put the alternative energy portfolio standard, which is actually leveling off this year in 2021, relative to solar and wind, some of the thoughts were, how are we even going to meet this? How is this going to happen? Are people actually going to build these resources? They even built a force majeure into that from the standpoint of, if it's not available, how do we get out of it, so to speak? And I think as we sit here in 2021, that almost doesn't exist. We recently put out a Finding Pennsylvania Solar Future report, which was somewhat of a policy signal to say, how can we get to 10% solar by 2030? And just by even laying out those recommendations and saying, this is something that we're thinking of doing beyond the current alternative energy portfolio standard, solar and solar developers are all over Pennsylvania, and it's exploding in the PJMQ with regards to what folks looking to deploy solar. So us making these policy bets, these creating information, getting it out there and saying, hey, how can we do energy storage in Pennsylvania? There's the potential for that to be, wrapped into a newer version of Pennsylvania's alternative energy portfolio standard. We're not aware that the governor's office or the legislature is specifically looking at a number, but when you look at states around us like New York and New Jersey and Virginia, New York has a 3 gigawatt energy storage goal by 2030, New Jersey 2 gigawatts by 2030, Virginia 3.1 gigawatts by 2035. So these are policy signals which are creating a marketplace to say, look, we want this in our marketplace. Some of those are procurement goals, some of those are essentially deployment goals. But I think the key with energy storage is, well, what are you deploying it with? I'm sort of borrowing this from somebody else. This is not my thing, but energy storage is like bacon. It's great all on its own, but it makes a lot of other things better, right? So what are you going to pair energy storage with? In our storage assessment report, we specifically talk about that PA solar future goal of 10%. And we say, well, that's 11 gigawatts of solar in PA. So what if 1/4 of that? What if that was our goal and 1/4 of it was paired with energy storage? Then what would that be? What would that, and that would be about 1.5 gigawatts in Pennsylvania. So we make those connections and then we do modeling on the economic benefits of that, how that could diversify our energy source as a sort of like let's put something out there and then let folks grab onto that and say, hey, you know what, that's a good idea. Solar's on its way in Pennsylvania. It's getting built out. So how do we pair energy storage with that? That's just one opportunity. There are lots of opportunities which we want to talk about here as well. But I think it's a way for us to send this policy signal that becomes a market signal and allows folks to say, yeah, folks are thinking about this. I'm on the right path. Now how do I get in the marketplace, and how do we use our manufacturing abilities in Pennsylvania to drive down those costs? They know there's a marketplace. They want to build. They want to compete, in this marketplace, and therefore that helps drive down costs and allows us to deploy for the greater good, frankly.
Perfect, thanks. And just a quick follow on. This is a political question, and you can pass on it if it's too political. But do you think that there is enough political momentum or mandate for the state of Pennsylvania leadership to adopt some kind of like actual goals? I am actually not familiar with PA's like where they sit in terms of energy technology. I know obviously there's the Republican side is going to be very supportive of natural gas and perhaps coal as well. Is it your perception that storage is viewed as a threat by that side of the political spectrum, or is it something that everybody can agree is useful and good? And I've heard both at different levels. I once went to Congress and talked to the subcommittee on technology and energy storage, and there was broad support for storage from both sides of the political spectrum. So in some areas, it's absolutely not that controversial. I'm wondering if you think it's controversial in Pennsylvania.
I think you're on to exactly what I was going to say, which is, when it comes to jobs and resiliency and opportunities for Pennsylvania, I think that's what everybody wants.
Right.
Once again, energy storage can be paired with lots of different things. There's some things that are ready today. There may be some things that are ready tomorrow or a couple of years down the road. I think it's incumbent upon us to sort of identify those opportunities and make it clear to folks, what the benefits would be from energy storage. So I think it's kind of non-controversial because, like I said, to some degree, it can be paired with lots of different things. I mean, when you look back and you say, well, wow, Pennsylvania has a lot of pumped storage. Why is that? I don't know that this is the exact reason, but it's been explained to me that pumped storage really helps enable our nuclear fleet.
Yeah.
So from that standpoint, it makes sense. Like the light bulb goes off. Oh, that's why pumped storage, is prevalent in Pennsylvania, and it's actually, we have a decent amount of it. Well, because we have a pretty large nuclear fleet. So to some degree, like I said, I think storage follows on with the other opportunities for diversification, for opportunities, and frankly, jobs and resiliency. And, I think that's what sometimes we need to talk more about, which is what is the value of that kilowatt hour when you didn't have it? And can energy storage help enable that? And that's a conversation that we need to continue to have, especially around, the weather events, which are driven by the climate crisis that we have. And so, that becomes more and more important in all of our communities all the time.
Perfect. Thank you. That's a good response. And I'll say I was actually surprised by the broad support that storage got. And I think the message from both sides of the political spectrum is that it does offer benefits in so many ways. So I'm glad to hear that that's consistent here in Pennsylvania as well. All right, Anouk, really, really quick, I want to make sure I tag up with you one more time too. This is going to be about funding and encouragement of new companies. And we've heard that there's a real appetite to have more domestic production. The more battery factories we can get in Pennsylvania, make batteries that are used in Pennsylvania that create Pennsylvania jobs, that create this infrastructure around it. There's a huge desire to have that. But then there's this question, well, which batteries and how do we get there? And as you've experienced, I'm sure both with your startup and also in your current jobs, there's a lot of hops that have to happen between, inception of a new technology to getting it all the way to something that's first production that's maybe sold at a loss, but at least getting revenue, and then actually getting something that has good revenue and good profits. It's a very expensive long-term process. And we've seen in the popular media and the financial media a number of battery-related companies, become more prominent. They're going through a SPAC, which is a way for them to become a publicly traded company by not necessarily, it's not an IPO. They merge with an existing entity and then they become this more prominent, more deeply funded entity. Some of these are doing okay. Some are doing poorly for a variety of reasons. I'm just curious what your perspective is, since you've been both on the VC side and on the tech development founder side. What's a good pathway for these companies if they really do have something that's relevant and can be manufactured? How do they get in there so they can start selling in the state of Pennsylvania or other folks?
Okay, so I think I can speak on the earlier stage a bit more than the later stage
Okay.
for a couple of reasons, especially, so yes, I'm on the VC side now, but this is a very recent transition, so I don't want to come across as an expert in that space. But as for the earlier stage and kind of how to pick the right technology and how to get a technology from the lab out there, so I'm a bit biased, but I think chemistry and material science can unlock a lot of technologies that have the potential to solve a lot of big problems. And there are incredible scientists out there in academia that have wonderful ideas and inventions, but they lack the support to transition these inventions out of the lab. I also think that sometimes they're maybe disconnected from the problem that they're trying to solve, or maybe don't understand it in a larger context, which is also part of the reason why I was interested in joining the VC side of science, to kind of understand the larger problems and motivations. So it's kind of a long-winded answer to explain that I think the support and the funding should start early, with a lot more entrepreneurial and business support for scientists in the lab developing these kinds of storage technologies, with support and help from government and policy experts like the folks on this panel, to help guide the problem at hand from the very beginning. So the science can be beautiful and work, but it's so crucial to keep in mind the techno-economics and the scalability of the technology. And so you spoke on this a few questions ago, just really focusing on the economics and the cost targets and how to beat them is crucial in looking at which kinds of technologies should we fund and support and transition out of the science world.
Perfect. Thanks. All right, so I'm going to now move to some of the questions from the audience. There's some good ones that are in the chat right now. I'm going to quickly address, one person asks, what is pumped storage? And again, just for the lay folks who are attending, this is when you have a body of water at a lower altitude, and next to it a body of water at a higher altitude, and you pump water up into the higher reservoir when you're storing energy, and when you're discharging, the water flows down through a turbine and generates energy. So you can imagine if you had a pump at the bottom of Hoover Dam, and sometimes you pump water back into it, you'd be able to use that water you pumped at some earlier time back when it flows through the generation turbines. And one of the interesting questions, why does Pennsylvania have so much pumped hydro? One, there's an appetite for it for integration of our assets. Two is we can do it. We have a lot of locations where there's these rolling hills that are in some locations 1,000 feet or more in difference locally in altitude, where you can put a dam up and create all this value just by moving water around. And so, it is by far the most prevalent energy storage technology in existence. And whenever folks say energy storage is a new technology, I'm always like, oh, no. There are, hundreds, if not thousands of gigawatt hours of energy storage out there right now. It's pumped hydro, it's used every day, and it's a huge asset. But it's not everywhere, and you can't put it everywhere. And so a lot of the problems and approaches and issues for energy storage are trying to find answers to, well, I would do pumped hydro, but I can't, right? The location is not right. It's almost impossible now to zone and create a new dam that fills up a valley somewhere. You're going to have all kinds of complicated public domain issues and wildlife encroachment issues. You can't do it very easily anymore. And so now we have to pivot to the next thing that's going to be useful and good. So that's that question. I've got one question. This is probably best for Dave, but considering the state of Pennsylvania, how can we lead the way in demonstration projects and stationary storage to buffer our growing wind and energy generation capacity? So the real question is, what leadership posture can the state take? Is it demonstrations? Is it creating? I mean, obviously we have a very particular solar and wind resource, and it's regional, even within the state. Is there a best practice that you guys have as a recommendation to make this happen?
That's a great question. And, I don't think there's a magic bullet kind of answer, but I can say from the standpoint of our office, we're taking a very much of a community approach lately, especially with regards to local climate action plans and things that folks can do in their communities, how they can see, touch, and feel opportunities that they can connect to. And so I think that when we start talking about deployment of energy storage, we first start at critical facilities, microgrids, things that are in your communities, whether it's your fire department, or whether it's the hospital, or whether it's the warming shelter, or it's the police station, those types of places that have critical loads. How does energy storage play a role in ensuring that those places are up and operating when you need them? Then on top of that, how do we pair that together with clean alternative energy or clean energy resources? And so therefore, then that's a pathway to how do we drive down our greenhouse gas emissions, and how do we sort of contribute to this clean energy economy? Like I said, folks tend to think of batteries. They tend to think of batteries with stuff they deal with every day. And more they're going to start thinking about vehicles and, electric vehicles that are driving around, that are plugging into their residence or into buildings, and how that becomes enabled. So I think that from the standpoint of how we look at opportunities for these technologies, we need to look at these opportunities in your community and how you can relate to them, and then say, hey, part of what occurred here was made in Pennsylvania. I have a job that's tied to delivering that resource, not only from a physical standpoint, but maybe also from a maintenance standpoint or from an installation standpoint. So, how do we do these things at the local level? And so that's kind of where we're going these days, is we like to have those conversations about those opportunities in your community to connect to what is essentially an economy around energy storage.
Perfect. All right, Briggs. I think I got I'm going to compile a couple of these and push it your way. And there's a couple of folks are asking, differentiate between the different kinds of energy storage. And I'm going to go back to the bacon analogy, which I think is delightful. Not only does bacon go well with many things, there's different kinds of bacon. You can have thick cut, you can have thin cut, you can have maple, you can have, veggie bacon. Maybe we should be talking about veggie low impact bacon that has less carbon footprint itself. There's actually a lot of different ways to look at this, because production of these storage assets often itself has a fairly significant carbon footprint. Understanding the trade-offs there, I think, are really interesting too. But a couple of folks are asking, what's winning right now? How does lithium ion compare to thermal storage, compared to whatever? And I'm curious how you handle this, right? Because as a technologist, type of person, as someone who's managing technologists, you're looking at integrating and optimizing complicated systems. You must have a lot of trade-offs that are at play. Do you have a couple of winners that jump out at you? Or what about flow batteries too? I knew it brought those up, and they are really compelling for long duration in some ways. I'm sure you're taking a portfolio approach, but in your sort of vantage, what's really interesting right now?
So I think it's important that we do some learning soon, to Dave's point. And so we've really invested in near-term pilots, trying to get some of that learning under our belt, with a target of 2025, sort of taking a slipstream of energy off of an asset and using energy storage with that. So we can do something at scale that has line of sight to the ultimate commercial application. And in that context, you're right, we are taking a portfolio approach, really a technology agnostic approach. We do think that probably short durations, let's say less than 4 hours, probably aren't going to cut it with respect to integrating with fossil assets, and also for sort of that medium to longer range energy storage that's going to be needed for grid reliability. And so when you get into that medium and long duration context, there's some near-term technologies that are a little more mature, say molten salt, which has been developed for concentrated solar power, for example, hydrogen, but also there's a lot of low TRL technologies, low technology readiness level technologies. I mentioned the natural materials for thermal, but there are some technologies that are a little more mature. The question is, do they have the cost? Do they have the efficiency? Do they have the range of benefits that you need for the various use cases? And so we're sort of sorting all of that out. And so I've got a sort of a hedged answer for you, Jay. Yeah, it's there's a huge range of technologies, almost too many out there. And I think it's too early to tell who's going to be the winners, but it's a pretty exciting time.
Yeah, that's my take too. And just to be clear, someone's asking exactly what is hydrogen. We're talking about taking water and splitting it and capturing the hydrogen gas from that splitting into some kind of storage and then using it down the road, probably in a fuel cell environment to recreate electricity. Although you can use hydrogen other ways too. Yeah, it's funny, 5-10 years ago, I described the battery landscape as the Wild West. It is still the Wild West. In fact, if anything, it's becoming more, it's proliferating even more. There's all these new angles and approaches in material science and chemistry, things that are going on that make this just like this really remarkably like diverse and complex landscape. And I think the lay public often struggles with what to think about it, right? It's very, those folks who are interested, and follow, Google News or CNN or whatever, every so often there's an article on, such and such, university or company has this new thing that's going to change energy storage. I can count on, two hands many times that I've read that and been like, yeah, is that real or not? And then you do a little more picking, and it's not depicted at all like what the reality is. There's some other, like, there's problems, or it's super early stage, or it uses platinum and they didn't disclose it, and now it's too expensive or whatever. And so understanding, like taking those nuggets and like drawing them out, which I tried once, the landscape is gigantic. And so I don't envy you actually, Briggs, because there's this knowledge that in 10 years, there's going to be a handful of winners, and there's going to be many, tens and tens of technologies that for whatever reason didn't cut it. Right now, we don't know which those are, right? And so I think your somewhat cagey response that we're going to pick the bacon based on a lot of testing and a lot of like sort of like development work is fair. And I also think, I mean, what I'll say just from my personal opinion is that if you're shorter duration, and I believe this is going to bleed into somewhere between 4 and 8 hours and less, lithium ion is going to be a really valid, near-term thing to install and use. It's happening already around the world, and the massive amount of global production of this technology is going to continue to support the electric vehicle transition, which I believe is now clearly happening. And I was dubious even a handful of years ago, but it's pretty apparent now that this is real. So that incredible, global infrastructure for producing those technology, that technology is going to really help other things. And something else that's kind of interesting, if you look at the prediction of global production of batteries for transportation, and you compare that to the predictions of the needs of stationary storage for things like we're talking about today, fossil integration, renewable integration, making the grid carbon-free or much lower carbon, that amount of storage is a fairly small fraction of the storage needed for vehicles. So the gorilla in the room is really vehicle transportation batteries, and in terms of global energy storage production. And understanding that landscape also makes you wonder, well, how much, is there ever a point where we're going to be like, no, we cannot use lithium ion, even though it's $75 a kilowatt hour? And I don't know the answer to that. Like, it continues to incrementally get cheaper and more appealing for a lot of things. There's obviously problems though. There's massive safety challenges when you have multiple megawatt hours of lithium ion under one roof. There's other challenges associated with sourcing and producing this much. I don't think anyone really has wrapped their heads around this collectively in a global fashion, how we're going to supply this many materials to this many factories in this period of time while keeping prices down. There's going to be some challenges to the supply chain for lithium ion batteries. And so that's where this other technology is going to come in. They're going to use non-lithium. They're going to have lower footprint. They're going to focus on thermal instead of chemical storage, that kind of stuff. So anyway, I digress a little bit, but I think it's worth talking a little bit about. Briggs, while I have you there, I got a quick follow-on question. We're sort of down to 9 minutes, so I'm going to try and wrap this up pretty quickly. But my follow-on question is, there is probably a future not too long from now where we start to decommission some of our coal-fired power plants, either in the state or sort of in the nation. But those plants already have electrical interconnects. They're positioned properly for integration into the grid. And there's a lot of data around historically what those different assets have done and produced. Is there a story where we integrate storage at those plants, where we actually maybe even retrofit or use some parts of those plants for thermal or electrochemical storage that is sort of, maybe it's a big flow battery, for example, where we have this next generation thing that sort of leverages the bones of a coal-fired power plant, but now it's like reducing emissions and creating efficiency as opposed to being a problem?
We think so. It's something that we're taking a really hard look at right now, and others are as well. Down in Alabama, a TVA coal plant was repurposed by Google into a data center. Out in the Midwest, they're using those transmission interconnections to put PV on old coal plant sites. In Pennsylvania, in the last 15 years, we had a huge number of coal plants shut down. I did the numbers. It's 44 coal units. It's nominally over 1,000 jobs.
Wow.
And we have an opportunity in Pennsylvania to perhaps bring that back, create some economic vitality in the state, but also do something that's really good for the grid that enables those renewables to come onto the grid in that low carbon environment of the future. So I think it's a really ripe opportunity. So yeah, we think so.
I feel like it's, you know, I've not seen too much analysis, but this idea has recently crossed my path, and I'm like thinking this is not only technically really viable, but politically and jobs wise seems to be a very reasonable pitch to go after. So I think it's a legitimate thing for sure.
You already dedicated the land. You already have access to the water. You already have access to the electrical infrastructure, and you have a trained workforce ready to go.
Yeah, it just seems like a no-brainer. And the last thing you said, the electrical tie-in is no joke. Like the one thing that people don't bookkeep in terms of economics of energy storage very often is the balance of systems. Not only do you have to have the batteries, whatever they are, you have to have power electronics, and you have to have all of the gear to like translate the energy onto the grid. It's basically already there at these coal plants. So why would we not try to leverage some of that one way or another? It seems like a really ripe concept, as you say. I love that. So Anouk, I got one last question for you, and it's really about, you know, in your experience in terms of being part of a startup and growing it, what does it take? Were you guys focused on economics or performance or fundamentals? I mean, you've mentioned physics and chemistry as like the underpinning thing, and there's all these great people doing this kind of work out there. Is that enough, or is there something else that has to happen to get to something that has the right sort of economics as well?
So we are, I mean, the startup's still around.
Yeah, tell us about that. How's that going?
Oh, they're going great. They're still ongoing. I just relocated to Europe for personal reasons, so I'm not there anymore. But they're in their first fundraise and moving on along and hoping to get a prototype by the end of this round. And it's early stage and very much centered on the chemistry and the novel compounds that they're looking at. And so I don't know what it takes. I kind of touched on that earlier, but it takes, you know, not only a strong scientific team, but also a lot of support to help to transition that out of the lab.
Got it. Thank you. All right, so we have 5 minutes. I think we're probably going to wrap it up. I don't want to go to the last minute and overflow. I'm looking through. There's a handful of questions that were asked during the registration process that I think we've touched on most of them. One of which I think is interesting, and I'm going to comment on and see if anyone else has some comments. But it's, what are the projections for the size of the long-term energy storage? And in this case, long-term is 100 plus hours, and how much this relies on policy. So over 100 hours, you're starting to bleed into what's known as seasonal energy storage, where you're holding it, and or you need that long of a storage, especially if you're backing something like a wind asset where the wind could stop blowing for 3 or 4 days, and you have to literally create a matched load or match the load in those cases, even though there's no wind for a long period of time, and then you have to recharge it slowly when the wind comes back, that kind of thing. That market is existing in people's heads right now. I think I don't know that we have decent projections. I'm working with a company called Form Energy in Boston, and they have a 100 plus sort of 100 hour plus technology, and they are, the necessary economics of that are incredibly challenging. Lithium ion is struggling to get under $100 a kilowatt hour. To get to this kind of marketplace, you have to get under $20 a kilowatt hour, maybe under 10, depending on the duration and where it's sited. That is incredibly challenging, but physically it's possible, right? So, and to the extent that it's possible, there's interest. So I think, and it depends on the location, but I think the best answer for this is that the market is enormous if you can do it, because pumped hydro is essentially this. Pumped hydro has, you know, the possibility to go to this duration. And so it's really much less about how it relies on policy and much more is, can the technologies actually be developed that are this cost point? So I don't know if any of the panelists have an opinion on this ultra long duration seasonal thing. Perhaps Briggs does, and maybe you have a comment, Briggs.
Quick comment would be that, you know, VRE has to be more than 50%. And it really only starts climbing up when you're at 70 or 80%. So I think we have a bit of time until we get there, but maybe in isolated parts around the country where we're really pushing it out, maybe it'll have a time and place sooner than that.
Fair enough. I totally get that. All right. So with that, I'm going to close this session. I really thank the over 100 participants we had attend. It was fantastic to have you guys tune in. I hope you all learned something. Please, you know, please circle back if you have any questions or comments on this session. And it was a real pleasure to have these fantastic panelists participate. We look forward to seeing you in the subsequent Scott Institute events. And gosh, I really look forward to seeing everybody in person someday. It's sooner rather than later. Please consider getting vaccinated, and we'll hang out in person someday. Thank you.
Thanks for having me.
Thank you.
Thanks for having me.
Anna, are we good? Anything else? Anna is muted, so we're just gonna sign off, everybody. Take care, and we'll see you all later, okay?
Thank you. Enjoy the day.
Bye. Yeah, you too.